welcome to this month's 2-minute tip from us, Sterling Geo, by me, Emily Winter. And today we're going to be looking at delta Q and change detection. So here I have two Landsat images open in my viewer. So these are to-date images of the same place from the USGS website from Landsat 5. And here we go, we can see Brecon Beacons here in the UK. We've got some cloud in time 1 here, and no cloud in this one. I've detected a small change over here. There you go, you can see there's a burn scar from a grass fire in one and not the other. If I just swipe here by right-clicking, you can see that appear there and that bigger spot appear there. Okay, so I'm going to fire up delta Q. You go raster, delta Q, wizard mode. This is the interface that will walk you through the process. You specify a file name, and then you select your images, time 1 here, time 2 second. So the earlier, most recent image here, previous image there. You select the sensor. If you have one of these sensors, you can do that, or you'll select other. Landsat 5. These are settings that I've used earlier that I could reuse here. And go next. This will crop the images to the overlapping area. And then you can do normalization. I know that time 1 has clouds, so I'm going to select that so that it makes the colours the same properly without the clouds skewing the process. Right, so then we come to the change detection methods you get in delta Q. So I have a long list of different change algorithms here that delta Q can use on your images for you. You've got tasseled cap green difference here and tasseled cap soil difference. Tasseled cap is a sort of vegetation study indice. There's lots of literature on this. So I'm not going to get into that now as it's a little bit complex. Here we have the greenness difference, so that's really good at looking at changes in vegetation only. And the soil is everything that isn't vegetation, so bare earth, soil, urban areas. We also have magnitude difference, which is a good all-round algorithm to use. So if you're looking at urban changes, this is a great one to use, and your general default. These two tassel cap greenness and soil difference will be greyed out to you if you're not using one of the sensors I mentioned earlier. Then you have single band difference, so if you've got panchromatic imagery, this is the only algorithm available to you. So that just simply compares one band to the other. Magnitude difference, I should say, compares the magnitude of a pixel at time 1 to the magnitude of that pixel at time 2. And the band slope difference takes 2 bands from each image and the difference between the two images, the 2 bands, and compares them. So band 1 and 2 from time 1 and band 1, 2 of time 2 compared against each other. Then you have redness, greenness, and blueness difference. These are really good for man-made objects which are red, green, or blue if you have one. I'm going to click interactive thresholds. I'll show you later why. And then we've got spectral segmentation, which will segment it into classes for you. And we have misregistration, which accounts for slightly misregistered pixels, so shifts in the image due to topographic effects and such. Also, we want to filter out anything that's too small. So anything under, let's say, 30 pixels. But we want to increase the max there. And we're going to change it to pixels rather than meters. Okay, next. These will also be greyed out if you don't have one of the sensors at the beginning and if you chose other. I'm going to leave these blank for now and just specify my image. You can also use an AOI here to specify a smaller area. I'm going to click finish and now we'll run through the process. Right, now our change detection thresholds have popped up, and this is because we ticked the interactive thresholds button earlier. This allows you to tell a delta Q how much something has to have changed in order for you to keep it in the output here. So anything that's going to come in the lower threshold, so anything that's got darker, is going to pop up in here as a sort of turquoise colour. Now here we go, now I can see some change coming up here. Obviously that's too much, that's taking anything that's changed even a little bit. I'm going to bring that back down to sort of the tail end of my normal curve here. I think that'll do. My upper thresholds. So I can see some cloud coming out here, which is not really what I want, but let's check. So there isn't anything else. Well, that looks like water there, so I don't think these are things that I'm actually looking at right now. So I'm going to put it all the way over there to take out any of it. Just going to open the threshold a bit. I could, actually, I'll do this. So get rid of the cloud changes. But we are getting some of those other changes. And there we go. And some of that speckle will be taken out by the area filter we selected earlier. Okay, click finish. You wait for it to do just the misregistration and some smaller steps here. The segment has gone red because no pixels were over the max amount of pixel values I specified earlier. I believe it will tell me that here. Yep, there was no segments taken out because there was none exceeding that threshold, which is good because I don't want it to take out any large areas at this moment. So here we go. We've got our 2-time images layered over the top here. You can use this to flick between them. You can use this to use the slide tool. You can also put a north arrow, measurements. You can do some measuring as well. A magnify view to see the overall. And your usual zoom, roam, pan tools here. Use your inquire cursor if you're interested in the pixel values themselves. So here's what we're interested in. We've got our change layer stuck on top of our image. If we click this off and on, you can see the image underneath and underneath. Thank you for listening to this month's 2-minute tip. There'll be more on Delta Q in following 2-minute tips. But for now, this was a really quick run through.